This is lesson 10.6. We're in our circles chapter, and we just finished the warm-ups. Let's go over it. All right. First set of problems says determine whether AB is tangent to the circle. And if the line is tangent, what is true about the line of tangency and the radius?
Perpendicular.
Makes a right angle or they're perpendicular. Good. Makes a right angle. So basically, we just have to see if Pythag works. If this, what they show you with all these side lengths, forms a right triangle. Okay, what do we think for the first one? Yes or no?
Yes.
Should have gotten yes. Okay, so you would do the 2 legs squared. You're supposed to see if that equals the hypotenuse squared. And it did. We got 361 equals 361. Okay, good. And the second one, here's my tangent line. Does that form a right angle with this radius length of 5? What do we think for that one? Yes or no?
No.
That one you should have gotten no. Pythag did not hold. 5 squared plus 9 squared is not the same as 11 squared. That's 106. Okay, so that's how you can check if the line is tangent. Forms right angle. Remember that? One of the theorems we talked about was if we had 2 tangent lines and they intersected on the exterior, the outside of the circle, that they were going to be equidistant from the point of tangency. The point of tangency is where it's tangent to the circle. So in this one, in number 3, you should have set those 2 lengths equal to each other. Solve for x. I got x to be 2. Okay, did we get that? All right, and then number 4, these ones are kind of fun. Same theorem, really. That all these points that intersect on the exterior of my circle and are tangent to the circle are equidistant from the point of tangency. So those would be equidistant, and so would these. All right, so they tell us we need to find x, y, and z. So x, 2x would be the same as 16. I got 8. Okay, folks, if this is 16, what's this measure?
21.
21. 37 minus 16 is 21. Yep. Good. So y plus 6 is the same as 21. Y is 15. And then lastly, 3z plus 1. Same distance as 7z minus 11. Solve that. I got z to be 3. Okay. Any questions with that? That's a review over what we did in the last lesson. 10.5, talking just about tangent lines. Tangent lines. Today we're going to talk about secant lines. So I think I did show these to you. I said, well, tangent means it intersects at exactly 1 point. I said, does anybody know what it is if it intersects at exactly 2? And nobody knew it. I don't remember that. But it's called a secant line. So secant, a line that intersects a circle and exactly 2 points. So this blue line right here, see how it's intersecting my circle at exactly 2 points? That'd be a secant line. Now this intersects my circle at exactly 2 points. What's this called? This is a chord. A chord can be classified as a secant line. What do we call this maroon one? Intersects only once. Tangent. Yep. That one's tangent. Actually, I want to go this way. Let's be consistent. Might as well keep going here with our circle vocab. Purple What do we call that? Radius. That doesn't intersect my circle twice, but that wouldn't be classified as a tangent line. Orange one, diameter. Okay, so today, our lesson, we're focusing solely on secants. I guess I should say solely. Secants, some tangents kind of come back. But basically, if we have more than one secant line, they're going to obviously intersect each other unless they're like going the same direction. But they're going to intersect each other, and there's a lot of like special relationships with the angles that they form and the circle where they intersect the circle. So we're going to look at those special relationships. But it's dependent on where, in reference of our circle, they intersect. So if they intersect inside the circle, or on the circle, or outside this circle, there's a kind of a special rule for each. All right, so we're just going to work our way through those three, starting with inside the circle. I did do some of my notes like in highlighters or pretty pens if you want to use them. All right, let's read through this theorem. This theorem says if two secants or chords intersect in the interior of a circle. What do we think interior of a circle means? Inside the circle, right? So in this picture over here, we have two secant lines. BD intersecting my circle twice at exactly 2 points. AC, another secant line, intersecting circle exactly twice. Here's their point of intersection. Did everybody see how that's located? Inside the circle. All right, so this theorem says if that happens, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Woofda, that sounds pretty wordy. Let me sum that up for you. So let's look at angle 1 as an example. So the measure of the arc intercepted by that angle would be arc AB, right? Arc AB, that angle forms that intercepted arc. And then the one across from it, so its vertical angle, would be arc DC. So this theorem says that the measure of that angle 1 is going to be exactly 1/2 the sum of those arc measures. So arc measure AB, and I always kind of say like the one across from it, arc measure CD. Okay, so if you have a highlighter, you can kind of, I highlighted my two arcs across me that are like in pink. All right, so if I was looking at angle 2 forms arc BC, and its vertical angle, or the one across from it, forms arc AD. So that's going to be 1/2 the sum of the measure of arc BC and measure of arc AD. Here's your rule. If the intersection point of the two secant lines or chords is inside the circle. Okay. So I got a few examples here. All right, and this first one on the left here, I actually have two chords. Two chords intersecting inside the circle. All right, so that theorem says that that inside angle is going to be 1/2 the sum of its intercepted arc, 88 degrees, sum means add, and the arc across from it, or the arc that's formed by its vertical angle, which would be this angle. It's as easy as that. Order of operations, start in the parentheses, add those together, you get 164. Half of that, 82 degrees. Please make sure you're putting degree symbols when you're measuring angles and when you're measuring arcs. I think there were some of you, I started grading your quizzes. I think there were some of you that forgot to put degree measures on your arcs. Oh yeah, and lost a 1/2 point. That was the only thing Brianna got. Oh, gosh, so close. One of these times, Brianna. I feel it. Okay. Next one here. This time, look at my variable. Okay, this time I actually have two secant lines. But the intersection point is still inside the circle. So this rule still applies. That x is going to be 1/2 the measure of this intercepted arc and the arc across from it. But I don't know those arc measures. Okay? Now, this is not a diameter. I think we can all visually see that this is not a semicircle, right? So I can't do 180 minus 96 to find arc, measure of arc xy. Ideas? Siler.
So you do the same thing, but the angle on the opposite side.
Like this one?
Yeah.
Let's call it y. I like this idea. Do
And
the same thing.
So once you find that measure, you'll 180 minus y equal x.
Perfect. X and y are on the same secant line. They're supplementary of each other, right? Or supplement angles. So we know y is 1/2 the sum of the arc it forms and the arc across from it. Good, Siler. So there you get 79. 62, 96, 158, half of that, 79. Okay, then Siler said, now to find x, since they're on that same secant line, we just got to do 180 minus 79, and we get 101 degrees. Good job. All right, the next one, a little different, because this time I know, again, I have 2 chords on this one. This time I know this angle in here, but I don't know this arc measure. So let's just set up our equation like we normally would. This inside angle, which we know is 60 degrees, is going to be 1/2 the sum of the arc it forms, which is x, and the arc across from it, which we know is 25. And then we just have a little equation we have to solve. No problem. A couple ways you could solve this. You could distribute the 1/2 if you want to. I don't like working with fractions. I'm just going to times both sides by 2 and get rid of that. And then I'm just going to minus over the 25. And I get x to be 95. Okay, so there's my rule with a few examples. If the point of intersection is inside the circle. Inside. 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 Okay, got it? Next rule. Now this one isn't hard to remember because it's really the same rule as inscribed angles. We already learned about inscribed angles, okay? So let's read through this theorem. This theorem says if you have a secant and a tangent line, so let's look at this picture here. This is going to be my tangent line intersecting 1. This would be my secant line. Take some if you want to. But you can see how their point of intersection is the point of tangency on the circle. So that's what it says. If a secant and tangent intersect at that point of tangency, then the measure of each angle is formed 1/2 of the measure of its intercepted arc. So if I look at angle 1 here, its intercepted arc is arc AB, and that's going to be 1/2 that measure. Similarly, angle 2 forms this arc, BCA. So angle 2 is going to be 1/2 the measure of arc AC. We should call that ACB or BCA, doesn't matter. All right, so here's how it's just like an inscribed angle. You don't have to write this down, just look up here for a second. So an inscribed angle is an angle whose vertex lies on the circle. And we talked about how that inscribed angle is always half of the arc measure that it forms, right? So this is really an inscribed angle. You can almost just think of it as it's kind of like an obtuse angle. So I have, here's my secant line, and my tangent line is just crossing through there. So you have this big angle here. It's still going to be half of the arc it's forming. It's really just like an obtuse inscribed angle, if that makes sense. It's just technically not classified as an inscribed angle because it's obtuse, larger than 90. All right, so let's try a couple of these. Find the measure of angle QPS. All right, so this is my secant line. This is my tangent line. Where are they intersecting? On the circle. Not inside, on the circle. On the border of the circle. So that means the measure of that angle is going to be exactly half of the arc it forms, which is 250 in this case. So that'd be 125 degrees. I like that rule. That one's pretty easy. Try one more. This time I need to find the measure of arc BCD. Okay. So I see this angle labeled right here with a tangent line and the secant line here is 108 and it's forming this arc. So I know arc, oh my gosh, I'm having a hard time talking. The measure of arc, let's call this DB. I'm going to set it up this way, actually, sorry. I know the measure of angle, ADB, which I know that's 108 degrees. Look at there. I know that angle is half of the arc measure. This is probably easier to set it up this way. All right, and this is 108. Essentially, you're just doubling it. So if you don't need to set up an equation, that's fine. But to find that angle measure, we just double it, which is what you're doing in this equation. 216 degrees is the measure of the green arc. Okay, I probably just made that more complicated than this. If you know this angle measures half of the arc, go the other way and double it. You don't need to set up an equation. I'm not asked for that arc measure, though. They want me to find this blue one. How do I find that? Alejandro? Yeah, well, the whole way around the circle has to be 360. And if the green one is 216, 360 minus 216 is 144. Okay. So there's if my intersection is on the circle. Last rule. This one's fun too. They're all fun. Have you guys ever learned something here that's not fun? I don't think so.
Something about triangles.
Okay, last one is if you have, and this one you could have a couple different types of lines. You could have two secant lines, like this one. That's two secant lines. You could have a secant line and a tangent line. Or you could have two tangent lines. But this one is if they intersect on the exterior or outside your circle. Okay, so see how all those intersection points are now outside the circle? Here's your rule for this. The measure of the angle formed is going to be half the difference of the measures of the intersected arcs. Okay? So here, the measure of that angle, I'm just going to call it angle A, is 1/2 the difference of the intercepted arcs. Here's the intercepted arcs. This one and this one. Now think about this. Could I ever have a negative angle measure here? No. So the order we're going to subtract them is the big arc. In this case, it would be DE minus the measure of the little arc. All right, and that's my rule anytime the intersection point's on the outside of the circle. Even if you have a secant and tangent, this would still be 1/2 the measure of arc DC minus, so big arc minus little arc, measure of arc BC. Okay, and even if we have two tangents, 1/2 the difference of the big arc, BDC, minus little arc, measure of arc BC. So what I like to remember for this one is big arc minus little arc. Can't have negative angles in geometry. There are some.
Have you seen negative angles exist?
Yeah, you'll learn about them in pre-calc. Yeah, pretty cool. It's not, but it just in shapes it can't.
I forgot how to do this one.
Try it. There's a button for it.
It only brings it for fraction of decimal.
Is it an irrational number?
Let's see.
Okay, well, I'll help you. Actually, you're taking quiz, aren't you?
Yeah.
Okay. All right, let's try some of these. Find the measure of angle 1. So here I have two secant lines. Where is their intersection point? Outside the circle. Outside. So my rule for that is the measure of that angle is 1/2 the measure of the arcs it forms. The difference, 80 degrees, big arc minus little arc. All right, that's 40, have a 40, 20. Pretty basic one. All right, this one's a little bit different. This time they're asking me to find the measure of arc JP. So again, I have two secant lines, and their intersection point is outside the circle, and it's forming arc JP. That's what I'm trying to find out. I might just call it X. And this arc, that's 70 degrees. All right, so I know that angle that's formed outside is 1/2 the difference of the big arc minus little arc, X. That's what I'm trying to find. You could probably like work backwards and like think in your head, like, okay, 70 minus what number when I take half of that to get 20? Probably do that. Here you can set up an equation if you want, times both sides by 2, get rid of that fraction. I'm going to add the X over. That arc measure is 30 degrees. Again, could probably logic or think backwards your way through that one, but they do get a little bit harder. All right, let's look at the next one. Find the measure of angle 2. This time I have a secant line and a tangent line. That's okay. As long as they're intersecting outside the circle, my rule for that is that the measure of that angle is 1/2 big arc, minus little arc. I don't know what big arc is. Ideas. Tyson? 360 minus 135. What else do I have to subtract off? Here's 130. 80. Good. 145. All right, 145 minus 80 is 65. Half of 65 is 32.5. Okay, I gotta do a little extra thinking there. Next one. Find the measure of arc XY. All right, well, first I have a secant line and a tangent, and I can see they're intersecting outside the circle. So 68 degrees, this picture's kind of confusing. 68 degrees is going with the angle measure because we're asked to find the measure of arc XZ. So I'm just going to call that X. Big arc is 224. So 68 degrees is 1/2 big arc minus little arc. And that's what I'm trying to find. This is similar to the one we did a couple times ago. Times both sides by 2. Okay, a couple ways you could solve this. You could minus the 224, divide by -1, or add the x over, and then subtract over the 136. I know a lot of you don't really need to show work to do that, and that's okay with equations. But after find x, oh yeah, that is what we were finding. So the measure of arc XZ, oh sorry, that's 88. I did my math wrong. 88 degrees. Arc measure, label it degrees. Okay, 2 more. Find the measure of angle 3. Here I have 2 tangent lines. Tangent line, tangent line. Where are they intersecting? Outside the circle. So the measure of that angle is 1/2 big arc minus little arc. I don't know little arc. Anybody little arc? Tyson?
360.
Is that what you're going to say, Alejandro? 140. Good, because they're tangent. They only intersect at one point, so those together would form a whole circle. All right, 220 minus 140 is 80. Half of 80, that angle measure would be 40. Okay. I want to see if you guys can get this one on your own. Last hour, I had 2 people get it right. Josiah and Isaac.
So likelihood of us getting it right.
So you got this! No, come on. That should motivate you. Can you try to get a pound right that Josiah got right? I'm not giving a whole lot of information. It's kind of a weird one. Alright, which one are you talking about? This one. Did you type in the square root? Yes. Then you're getting an irrational number. And I told you this before, you can't do that. You gotta type in what's underneath the square root, make that a fraction, rationalize it yourself. Because you can't turn irrational numbers into fractions. That's what an irrational number is. just a second. I'm gonna. Trinity got it. Close, but no. You got another? Kind of close. 1/2 minus 1 drone. Yep, that's right. That's the one on it. Oh, dang it! Did it quite need 7 hours? 2 for 2. Okay, you guys did it the same way I did. I think.
What was that?
Yep. You'll never know. I'm not going to show you.
Right.
Okay, here, ladies. Sorry, I don't know why I keep reading. Okay, so the right answer was 264 degrees. Here's how. So we know it's intersecting outside the circle, right? And we know this one's 84 degrees. So what these ladies did, got 2 tangent lines, they called this little arc X. Meaning this arc would be what? 360 minus whatever X is, right?
Oh.
Has to be. So we know 84 is 1/2 big arc, 360 minus X. 1/2 big arc minus little arc minus X. And then they solve this for X. So negative X minus X is negative 2X. Times all sides by 2, 168. Add that over. Take off your layers around X. Again, you don't have to add that over. I just like to keep my variables positive. But we're not done. That only gives me little arc. Little arc was X. Look at what we want to find. We want to find the measure of arc DPA. That's big arc. So we'll just have to do 360 minus 96. And that is how they got 264 degrees. Nice job, ladies. Just like I made like a triangle thing. I don't want to show you because it was kind of confusing, but it worked. Well, maybe I'll show you when the recording's done. Okay, the only last thing, the notes here. This is just a summary of basically like it's your cheat sheet of the 3 rules. It's a good kind of like reference in your notes. So if your intersection point's on the circle, here's your rule. You don't have to write anything in this chart. I filled it out. Inside the circle, here's your rule. Outside the circle, here's your rule. That's it. Okay, I'm gonna try to get it inside.
Sure.